Hello, everyone. It's Kene once again. All right. So, guys, it's another Python program that we are going to solve today. Okay. And again, it's a maths question. It's a problem that involves converting. Well, we're actually going to convert a number in base 10 to um, its equivalent in some other base, not exceeding 9. Do you understand? So I'm just going to share my screen and we have a look at the question together. Yeah, guys, I won't be using my video because, yeah, it's night time here and I do not have um, light enough. Okay, so just bear with me. So let's look at the problem together. Write a program that takes a number in base 10 and displays its value in a base not exceeding 9. So this is it. I take a number, say 56. Okay, let me take 34, for instance, right? That's in base 10. Base 10. And the problem is, what will be its equivalent, say y, in base, again, we assume 2. So that should be 2 there, right? 34 base 10, y base 2. So what's the value of y? That's what we're asking in essence. And we know how to go about it. So we're going to take 34 and we divide 34 repeatedly. Like we divide 34 by 2 the first time. And what we get as the answer after the first division, we again divide that by 2. And the answer we get, we divide it by 2. The answer we get, we divide it by 2. So we continue the division until what is left is not up to that base, that is 2 in this case now. So we keep dividing until what is left, or what is left is not up to the number that we are using to divide. And then afterwards, we would collect all those remainders, so to say. We get all of them together, just bring them all together from the bottom to the top. So that's from bottom to top, bottom top collection. Okay, right. So let's have a look at it, guys. So I take 34, divide that by 2, right? And that gives me 17 with a remainder of what, guys? 0, right? Great. Then I'm going to divide that again. This time it's 17. Again, I'll divide by 2. And what does that give me? That gives me 8 with a remainder of 1, right? Then I take 8 this time. 8, divide that by 2. That gives me 4 with a remainder of 0. And then I take 4 this time, divide by 2. I get 2 remainder 0. Then I take 2. Take 2, divide it by 2. I get just 1 with remainder of 0, right? Then I'll take 1 now. Now, guys, we see that 1 is not up to 2. So there's really not going to be any division, like so to say, right? I'm just supposed to take the 1 and bring it here. So doing that, so I'm just going to, do this division. but it's going to come back to me as 1. So that's going to be, I'm just going to put 0 here with a remainder of 1. So whatever I have here that is not up to the divisor, that will be the last number as the remainder, so that when I'm collecting the remainders, I actually begin with that last number. So that's from bottom to top. Do we get? All right. So 34 base 10, what would be the value in base 2? That will be 1, 0, 0, 0, 1, 0. That is going from top to, from bottom to top. Right. So that's it, base 2. Base 2. Okay. I hope we get it, guys. How about 34 base 10 to base 3? So let's have this way. Base 10, what would be x when it is base 3? All right, so we start again, guys. 34 divided by 3, that gives us a remainder of 1. So that's like 11 remainder 1. Then I'm going to take 11 divided by 3. That's going to be 3 remainder 2, right? Because 3 multiplied by 3 is 9. 9 plus 2, 11. So that's it, guys. Now I'm going to take 3. 3 divided by 3, that is 1 with no remainder. 1 remainder, 0. And I have 1 here now, right? It's not up to the divisor. 1 isn't up to 3. So I'm just going to take the 1. So I'm just going to say 1 by 3. I'm going to take whatever I have here now, guys, as the remainder. That's what's remaining. So this will be 0, remainder 1. All right, so when I collect bottom to top, it will give me in base 3, 34 base 10 will be 1, 0, 2, 1. Do you guys get? All right. So guys, that's how we get the value of a number in base 10 to, that's how we get a number in base 10 to its value in some other base, right? Now, how do we write the code, the Python code for this same thing here? Okay, let me not erase that yet. So to do that, guys, I'm going to get input from the user. So I'm going to get the number and the base that the answer should be in, right? So I'm going to get the input. I'll call that imp, and I'll call the input method here, which is going to be enter a number, right? Then a whole number, guys. I just think that in this case, I should just restrict myself to a whole number. Then I'm going to take, as for the base, so this should be t base. I'll store that in a variable called t base. Then input, enter a base for the answer, right? Just something like this. Then I am going to, when we get these inputs, it's obtained as a string. I need to convert it to an integer, so to say, right? Then I'm going to take the imp. Another thing, guys, you can do is to just get this input, and everything inside becomes the argument for this int method, right? So it's now an integer, so I don't rewrite that. Int again. So just like that. I know perhaps I haven't done this before, but it's possible to do it, right? This way. Then I'm going to create the loop. So while, I'm using a while loop here, while I, that is the variable that keeps track of the number of times we have gone in the loop. So while I in, sorry, I don't need to use the in. While in this case, I have to do something quite different, guys. I'm just going to say that imp, provided that it is greater than 0. You know that the number must come down to 0 at the end of the day. At the end of the day, it must come to 0, right? So we are saying that while that input is greater than 0, it should do something. We need it to do division, and we collect the remainder. And how do we get the remainder after a division operation? We use the modulus operator. Do you understand? So that gives us the remainder from that operation. So I'm going to store that in a variable. I'm going to call it remaining. Just call it remaining. Yeah. Then it should be imp modulus t-base. So that gives me the remainder. That remainder is stored in that variable called remaining. Right. Then the next thing, guys, I'm going to do is, let's go back here. I'm going to create a variable to hold the remainders, right? So as I get a remainder, I'm going to append it to what was there before in this S variable, that is the container for all the remainders. Okay, so I'll set it to an empty string at the beginning. Right, then I'll come here, guys, and this time I want to get the new value of imp after the division, because this here gives us the remainder. But what about the value itself? What do I get? The new value following the division operation. So I'm going to set a new value for the input as what I get when I divide input by what you guys know already, right? By the t-base, by the base. So what is this, guys? I know I haven't talked about this in my videos. Now, this is the floor division. It's called floor division, or what we call truncated division. What does it do? Now, let's give an example. You know, when you divide a number and there's supposed to be a remainder or a floating point number result. So we get a floating point as a result of that division operation. That's what you get. So let's say 7 divided by 5, and I'm going to get something like 1 point something 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 something, right? Great. Or take, for example, 5 divided by 2. That should give me something like 2.5, right? Something like that. But if I'm using this truncated division, it's just going to come back to me as 2 alone. That is the whole number part of the result alone. So no decimal points, right? That's what I need here. And that's why I'm using this truncated division operator, right? So I'm going to get the new value of the imp by doing imp divided by t-base, and that new value will be restored in this variable called imp. So that's how I get the new value for imp. So I'm sure that it is reducing. So it is reduced, imp is reduced here. And again, I will check if that reduced value of imp is greater than 0. If it is, then reduce it again. And you keep checking to make sure that you haven't got a number that is less than or equal to 0. If we get it to be 0 or less than 0, then the loop is going to break, right? And that means that's the end. So, guys, the next thing I'm going to do is get that string variable and append. So the current value of that string variable, which is empty in the first iteration, I'm going to take it and I'm going to join the remaining. You know how I got this remaining here? Well, that's the remainder. So I'm going to join the so-called remainder, which here is called remaining as a variable name. So I'm going to join it with this S, and we're starting out with an empty string. So the first remainder takes is appended to the empty string. Then in the second iteration, that other remainder, the second time we get a remainder, you know that there's already one remainder here. So we add the second remainder. So there are two remainders. It goes again, we go round and we come back here. That's the third remainder. We join it to the two we already have here. So that's how we keep joining the remainder to what we already had, right? So that's what we call concatenation, kind of here. That's why I'm using this plus sign. So it's not like the arithmetic addition that we know in maths. It's just keep joining or appending, so to say. Append this value to what was there already. All right. So having done that, guys, you know, I said that we are going to take it from bottom to top, bottom to top. But what we have in S is going to be taken from top to bottom. That's how it will be read and displayed to us. So we need to reverse it. Instead of going from top to bottom, which is not what we need something from bottom to top. We need to reverse the order of the numbers, the order of the numbers in S, in this string, right? So how do we reverse the order? Guys, I'm going to use something that has to do with slicing, right? Slicing strings. And yeah, it will appear as magic, but we'll explain what is happening there. So I'm going to take a new val. This time I need to come out of the loop. So I'm done with collecting all the remainders. So I need to step out of the loop and take the new val. Take new val to be what I have as the string. That is all the remainders that I need to reverse. I need to reverse the order of the items in the string. Then I will do this, guys, colon, colon. Now, this is, all right, computer, go through the numbers beginning from one end to the other end. Beginning from one end to the other end. Now, this first one now, because I have -1, you know, -1 starts counting from the back. So this here is like the right end, and this is the left end. And I'm going to go from back to front. That's why I have the -1. So taking the values from the end, that's why we have the -1, guys. Don't forget that. Right, and that's it. So I've taken the numbers in reverse order, and that recreates a string, which I have saved in new val. Then, lastly, I will show us the result, and that result is the new val. Just as simple as that, right? So guys, let's see. I'll take this off. essay. I run the program. Run sorry, I need to see what I have here. It's not the main. What is it here? Okay, so I'm going to run this. Enter a whole number. I will say 34. Enter a base for it, base 2. And what do we have? Oh, an error. Type error can only concatenate string, not int. So if I'm going to concatenate string to string, they both have to be strings, right? We can't try concatenating int to string. So we need to fix that. And that was an oversight on our part. You know, we converted the imp and the t base to integers specifically, right? And the remaining, this remainder here is coming to us as an integer. But the string here is a string. This S is a string. So I'm trying to join a string with an integer, which, you know, the integer there is the remaining. So that's not possible. So I need to cast it. I need to convert it, type conversion there, using a method called str, the str, and this takes that integer as an argument. Why isn't this? Okay, right. So that's just it. I believe this should work now. So this now is a string that I can concatenate to a string. All right, so let's see, guys. Enter a whole number, 34, and the base should be 2, and that gives us 100010. Let's be sure that it is correct, right? So I'll do that manually, and then we'll call it a day. 34 divided by 2. So that gives me 17 remainder 0. Then 17 divided by 2. That's going to be 8 remainder 1. Then 8 divided by 2, that's 4 remainder 0. Then 4 divided by 2, that is 2 remainder 0. And then 2 divided by 2, that is 1 remainder 0. And because this new value here, 1, is not up to the divisor of these 2, I'm just going to take it as the remainder. So 1 becomes the remainder. So I'm just going to do 1 by 2, and that simply gives us 0. So just 0 comes here. And I'll take that new value as the remainder, making 1. And then, guys, you know that we are to take it from bottom to top. So if we had not reversed the order of the string, it would have come to us as 0, 1, 0, 0, 0, 1. That's not what we need. We actually need 1, 0, 0, 0, 1, 0. So that's why this is correct. 1, 0, 0, 0, 1, 0. So that's how we solve this problem. Any base at all. So I can even make it base 3, 34 base 3. Let's try it and see what we get using 34. All right, I need to get this off, guys. Then run this. So the number is 34. and the base this time should be 3. And we get 1021. I hope we understand this. So thank you guys for watching. I'll see you in my next video. So in the next video, we're going to convert numbers to base 10. So it could be a number in base 2, which would convert to a number in base 10. That should be the next problem we'll be solving together. I'll see you then, guys. You have a great day. Bye.